Hi, welcome to an Arduino tutorial from Robojax. My name is Ahmad Shamshiri. In this video we are going to learn how to build a digital clock using any Arduino with DS1307 real-time clock module and this HT16K33 7-segment display. You can get the datasheet and other files related to this by clicking the link below the video in the description, which will take you to robojax.com/learn/Arduino. Let's get started with this. I have a separate video explaining this DS1307 with example, with alarm and so many other options, and also a separate video fully explain this HT16K33. I'm not going to explain those. Here we are going directly jump into wiring and coding. I'm going to explain the code fully, demonstrated different features of it, because this can display seconds. You can turn it on and off, either the second can blink or it will be just a counter. Without further ado, make sure to thumb up the video and also subscribe so I get started with this. This is a 3.2-inch TFT LCD screen based on ESP32. This has built-in Wi-Fi and Bluetooth and can be programmed with Arduino IDE. The product is from Maker Fabs and it has built-in camera. You can play simple games, you can display text, and you can use full features of ESP32. I have an introduction video for this product. The link is below the video in the description. If you want to purchase the product from makerfabs.com, the link is also below this video. Now here I have used from 5 volts. I've connected one wire from ground, from A4 and from A5. A4 is SDA, A5 is SCL. If you're using other devices, for example UNO Ethernet, SDA is A4, A5 is SCL, Arduino Mega 20 is SDA, and 21 is SCL, and the Nord and Duo, they have been all mentioned. I will provide you the link for this as well. And then from here I have connected one bunch of wire for the real-time clock and one bunch of wire of the same color to this display. For the display, they are exactly the same order from left to right. They are coming from left to right, so you don't have to worry. 5 volts, ground, SDA and SCL. And here for this module, this purple is 5 volts. 5 volts have been connected to VCC, to the second pin, and then ground is gray, has been connected to the first one, and then white is SDA, has been connected here to the SDA pin, and the last pin, black, is SCL, and it has been connected to the last pin, which is SCL. Now let me explain the code. Because I've used library for DS1307 from Adafruit and I've used HT16K33 libraries, first you need to download and install this library, and then we need to install this library. For this is called RTC-LIB, that's from Adafruit. Let's go to Sketch, include library, manage library, or you can go to Tools, manage libraries. Wait for this to complete the bar graph, and you see RTC-LIB, just type RTC-LIB, wait for a few seconds, and here it says RTC-LIB by Adafruit, and here is the name of the person, Glab. So select that and install it. Install it. Wait for this to complete, and the installation is now completed. And then type here, and then for HT16K33 type and wait. You will see a lot of options, but the one that we are using is from Rob Tellart, and it says installed, and in your case the install button will be here, and just click and install it. and then close this. This line wire is for I2C communication. It's part of Arduino. RTC lib is that Adafruit library for real-time clock, RTC. So we are including the library here, and from this, inside that there is a class, and we are creating an object called RTC. And this, from this class for display, we use an instance of it, and we create a object called segment. And this, and here we define the, and here we set the I2C address 0x70. Watch the introduction video to this so you will understand why we need it. And these are the settings for the clock. Here we say show clock, show second, true. If we set that to true, you will see here the time, the seconds will be displayed. And this one, 10 seconds, mean after 10 seconds this will be displayed. Whatever time you set, that is the intervals. And the blink, if you set this to 6, 3, or 5, so that number of times the second will blink. And if you set it based on not blink, based on time, then it will be for 5 seconds. It will display without blinking. And here show leading 0. If you set that, you will see this. If it is less than 10 o'clock 9, or from 1 to 9, from 0 to 9, you will see leading 0 here. But if you set this to false, you will not see it. And also show second no blink. If you don't want this to blink and just increment the number, set this to true. This is used inside the code. Show second 1, show second 2 are functions prototype that are used within the code. This is part of the clock to display it on the screen if you use it on the serial monitor. Inside the setup, we check for Leonardo, micro, and 0. If serial is not available, it will just stay there. And this line initializes the real-time clock, RTC.begin, and this means not. If it is not true, if it is not initialized, then it will print this error for you, while 1 mean keeps it forever waiting. And again, there is another function is called is running. This is just redundant, you can remove it. And this line is printing on the serial monitor this text. This one that you see is coming from here. This 9600, if you click on tools, serial monitor, or press Ctrl+Shift+M, or click in here, the number that you see on the right side on the lower section is 9600. If you set different number, you will not be able to see this text. Make sure to set it to 9600 so you can see the text. And this line, if you want to set the time, use it like this. RTC adjust date time. When you say date time, it takes the time and date from computer. Whatever is on your computer, it will be transferred here. And I've not updated it. But if you want to use your own time, then do not use this date and time, and enter manually. This is the year, that's the month, that's the day, hour, minute, and second. So uncomment that and set your own time. So this will set your own time. But you need it only once. You don't need to set it every time. You just need it only once. And once you upload it, the time will be set. And this segment.begin, that's for the display. That's for the speed of I2C communication. That is displaying, that's setting the display on. So turn this on and sets the number of digits to 4. And this sets the test when you restart it. If I restart it, you will see one test. It turns on all the segments. And this will turn it off because some of the segments will stay on. So we'd have to turn it off, 50 millisecond delay, and then turn it on. And then this sets the brightness from 1 to 15, which I'm going to demonstrate it. And from here we check if show leading 0 is set to true to display 0. Then it set the display to 4, otherwise it says set to 3, so this means otherwise. So it will set 3 digits so that 0 will disappear if you don't like it. And here we initialize the RTC, we create an object called now, which we will use to get the time. And here segment display time, this will display time, and we pass hour using this now.hour will get time for hour, and now.minute will get the minute from this object, and we'll pass it to the display. Display colon 1 mean display this colon, keep it on for 500 milliseconds, and display 0 mean turn off, and it will turn it off when the time is displayed. So that blink is coming due to these lines. And here, if we want to display the second after a few seconds, here show second no blink. If that is set, then we go to show second 2 function, otherwise we go to show second 1 function, which I'm going to explain them. And here show second 1, we get the second blink count, how many times you want to blink it, and we store it here so we can update this, not this. And then here if show second is set to true, which means to display the second, then we get the current millisecond subtracted from the remember time, which we give this millisecond to this, because this will increment continuously from the time that you start Arduino. And we check it if it is greater than, let's say if it was set to 5 seconds, then we know that okay, the time has passed, let's go for the count. And then the while will go with a count. If it was 3, so if it is greater than 0, which means 3, then we get the time, and then we increment the decrement the count by subtracting 1 from it. And in this line we set the digit to 2, so the minute and hour will disappear. And then we display now second. The second will be passed here, and that's coming, and this will turn it off, keep it on, and then turn it off, and then keep it off, and then turn it on. So that's why it was blinking. And then we set the time, so we know how much time has passed. We just remember this to this variable. We do exactly the same with show second 2. The difference is this time the count is not 1 or 2 or 3, but it is 5,000 millisecond or whatever second you want. For example, 3 seconds for this to be displayed. So the counter will do the same thing, except we don't have here turn off and on. Here we have display off and display on with some delay, so it was blinking. And here we don't have it, we just wait for 50 milliseconds. It will run the loop, this while loop, until whatever time you set, past like 4 seconds, 5 seconds, it will display and disappear. And then print time will print the time on the serial monitor, which I just showed. And here now let me demonstrate it. As you can see, the clock is running, and let's first set the time, not with the computer, but our own time. The year doesn't matter, that's month, day, and hour. Let me set it to 8 and 1, and let me upload it. So you will see the time will set from here 8 and 1, and it started. But and if you want to now display the leading 0 here, if you set this to false and upload it, and you will see that the leading 0, once the code is uploaded, will disappear. And now if you say show blink, no blink, right now look, after this 10 seconds it goes here and blinks 6 times because it is set to 6 times. Let me set this to 5 seconds, and here we say no blink. If you say no blink to true and upload the code, then when it shows the second, it will not blink, it will be just a counter. Now 5 seconds. I set this to 5 seconds, and now it will be just number will increment and it will come back. And here shows second. If you set it to false, this will not be displayed, and the code, when the code uploads, this is a test. So now it, after 5 seconds or whatever, it doesn't go because we set it to false, and it will never display the second. And this line sets the brightness. If you set it to 15, it will be very bright. Let's see, my room is a little bright. I hope you can see the difference. Now it's very bright. Now let's set it to 1, very dim, so you can see it, the difference perhaps on camera. Now it's very dim, but I'm going to put it to 10, which is because in some environment you need to dim it, because otherwise it will be very annoying in dark rooms, and also save energy if you want, and power it up with battery. Now let's set the time back to my computer time, whatever it is. Upload it. So it will be this from my computer, whatever I have, 11:08, and you can see there is few seconds delay, 2 or 3 seconds when we upload the code. So keep that in mind. There is a delay because when the USB puts a code and compiles it, it gets the value and takes some time. Thank you for watching an Arduino tutorial from Robojax. If you learned something and found this useful, please thumb up, as this will help my video in the search algorithm of YouTube. If you have comment or question, please post it at the comment section below. I try to answer and reply. And don't forget to subscribe so you get updates of my upcoming videos. A separate video with digital clock for this DS1307. Make sure to watch that video. The link is below the video in the description. This tutorial I'm going to show you how we can build an LED 7-segment display clock. That's why we are using from pin 2 to 13. And here is the wiring diagram. Then we have C, D, E, and because we have 6 wires here, 6 pins on this side, an issue here with the blink. This goes half a second. In this tutorial, we are going to learn how to use the millis or millisecond in Arduino programming. In this video, we are going to do the LED blink with different duration, on time and off time, using millis. We're not going to use the delay.